Okay, oops. Matt tells me to go ahead and get started, so I'm going to go ahead and get started. So, many thanks to Matt and to the organizing committee for allowing our panel to talk about starring the Earth, our science, our planet, and the plurality of worlds. I can skip introductions because we've just went through introductions, but our panel consists of me, Graney and Danielson on the far end there, Paul Gabor next to him, and then Steve Dick, and who we've all had introductions to. And also on a recorded video from Rome, Guy Consolmagno, who's the director of the Vatican Observatory, who, for the purposes of this talk, his CV includes being a member of the Science Advisory Board of the SETI Institute. And he also has general interest in sort of broad questions of science that led him to write a book with me on called When Science Goes Wrong. So, which is mostly history of science work, which I'd love for you all to read. So Dennis, in my book, A Universe of Earths, Our Planet and Other Worlds from Copernicus to NASA, is now in the press with Oxford University Press. In it, we argue for a revision of how historians, astronomers, and the broader public all see the role of science in the story. In the story of the Copernican system, the plurality of worlds, and the place of our Earth in the universe. So what we're going to do is Dennis and I are going to present a couple of synopses of our central argument, which is seen from the standpoint of science, me, and from the humanities, Dennis. And then we've asked for critical responses from our panelists who got a look at a late draft of the book, not the final draft, but a late draft. So a standpoint from a historian of science, Steve, who knows like everything about this subject, and a couple of working research astronomers, Paul and Guy. So for my comments, an important part of our argument is that ideas in science can get a footing even when science stands against them or offers nothing to support them. So this picture is from Otto von Guericke's 1672 New Magdeburg experiments. And this is, I would call this diagram, a bit of practice in the production and transmission of astronomical non-knowledge, if you will. So it shows the planets increasing in diameter with distance from the sun. And this notion had its advocates in the 17th century, despite telescopic observations of the planets being clearly contrary to it. Indeed, here is Christian Huygens' diagram from a quarter century later, visually transmitting a more correct astronomical knowledge regarding the sizes of the planets. But when he published this, he included the comment, "'Tis remarkable that the bodies of the planets do not increase together with their distances from the sun, but that Venus is much bigger than Mars." It was such a cool, interesting idea, this diameters thing, that they would increase with distance from the sun. So we argue that the idea of a universe of other Earths was another interesting, cool idea that caught on despite contrary evidence. We see this at 2 points in history, 2 junctions on the road to the plurality of the worlds. The first is the early 17th century with Johannes Kepler. If you've seen one of my previous presentations at these workshops, you know I tend to talk a lot about star sizes, okay? And I tend to show this diagram here by John Herschel, visually transmitting a little astronomical knowledge about what a star looks like as seen through a very small aperture telescope, such as those used in the early 17th century. If one does not know that this appearance is a product of optics, is wildly inflated and not an image of the physical globe of the star, one must conclude that this star is no sun. The apparent sizes of all these fat stars in the sky combine to be some decent fraction of the apparent size of the sun. But the light output of the combined stars is, as Kepler says, almost infinitely less than the sun. And if this fat star is at a Copernican distance, it must utterly dwarf the sun in size. Therefore, stars must be bodies far dimmer than and far larger than the sun. Kepler argued and embraced this idea, arguing the uniqueness of the Copernican sun against Giordano Bruno's stars as other suns orbited by other Earths. Given the available knowledge, Kepler's argument was rock solid, based on easily reproducible observations in basic geometry. Kepler's science stood against Bruno. Nevertheless, Bruno's idea of a plurality of worlds became popular anyway. It was such an interesting, cool idea. The second junction point is in the late 19th century, when it had become clear that planets were not all Earths, stars were not all suns, and life was not a regular product of matter. Here in the book, we focus on William Whewell, Agnes Clerk, William Thomson, respectively. Regarding Whewell and his argument for diversity among planets, we thank much and borrow much from Mike Crow here at Notre Dame, who had much to do with causing these History of Astronomy workshops to exist. Clerk made clear to a broad audience that stellar distances measured through parallax showed that some of the night sky's bright stars are very distant, and some of its faint stars very close, meaning that there's a great diversity in stars. Thomson recognized the implications of the decline of the ancient theory of spontaneous generation and proposed the idea of panspermia in its place. But in an evolving universe of diverse planets and diverse stars, panspermia has its own problems. While Kepler's science-based challenge to a plurality of worlds faded with advancing knowledge, those of Whewell, Clerk, and Thomson remain today. At either of these junctions, science pointed to an exit ramp off the idea to the plurality of worlds, off the idea to a universe full of other Earths. And note here, full is the word that we use. The Whewell, Clark, Thomson challenges do not mean there are no other Earths, or that looking for other Earths is a futile exercise. But no one took the ramp. A universe full of Earths is so interesting and so cool and so popular today. And importantly, in a less Earth-filled universe, all the stuff that today gets everyone's attention becomes much less plausible. Both the serious stuff, like proposing that an object passing through the solar system is a piece of extraterrestrial technology, or the other stuff, like equating UAPs with craft piloted by extraterrestrials, that nevertheless makes it into reputable media and can be a real problem for science, at least in my opinion. And so now, as my little bit of overview, I will pass this over to Dennis.
Thank you, Chris. And I just want to begin with an expression of warm gratitude to all of you for being here. I especially want to thank Chris, with whom I've done something I've never done before. And I don't mean drive cross-country from Louisville to South Bend. I do mean co-author a book. And for me, this couldn't have been a happier or more satisfying experience. It's also an honor to welcome to this session probably the world's most accomplished historian of plurality of worlds, even though we're sort of killjoys in that respect. And I don't have any pictures. I'm a humanities guy, I'm a textual guy, so I'm just going to talk at you. Our book is intended as a celebration of the history and genuine science that hatched the momentous conception of Earth as a planet, or to use classical language, as a wandering star. In the process of telling our story, we also inevitably engage issues related to the plurality of worlds, which I'll probably just abbreviate as POW. Doesn't mean prisoner of war. Plurality of worlds. Our working title was Starring the Earth, Our Planet and Other Worlds from Copernicus to NASA. However, the double, I would say, poetic meaning of starring seemed to confuse some of our editors at Oxford University Press, to whom great respect is due, but they downgraded our title to A Universe of Earths, Our Planet and Other Worlds from Copernicus to NASA. And I'm going to argue, not to you, but to them, that we replace the colon with a question mark out of honesty, because the title and subtitle, between the title and the subtitle, because the book really does interrogate rather than proclaim plurality of worlds. And in the process of studying and sketching a story that included POW, we identified a number of features of POW literature that we thought worth unfolding. And one of these recurrent features is recourse to cliches that superficially seem to have some kind of probative force, but in fact dissolve when examined rigorously. Sir Martin Rees is reported to have coined the truism, which was repeated by Carl Sagan and others regarding extraterrestrials. Absence of evidence is not evidence of absence. This truism certainly has a QED ring to it, but our friendly response is itself a tautology. Absence of evidence is absence of evidence. Or maybe absence of evidence really is evidence of something at a certain level. Perhaps 60-odd years of serious but fruitless searching for signals from the stars does tell us something. Surely it at least undermines what Frank Drake in 2008 called his almost absolute certainty that radio waves sent forth by other intelligent civilizations are falling on the Earth at this very minute. And again, I emphasize disagreement is not disrespect. But here's another feature of POW theorizing that we find dubious and deleterious. There's a long history of what we call pluralistic misanthropy. A misanthropy that seems absurd given its lack of scientific foundation. We co-authors are not disinterested parties in the conversation and the history we pursue in our book. We have great affection for history and science. Affection rooted simply and elementally in profound love for our home and native planet, for its inhabitants, present company not accepted, and for getting their story right. So we're astonished not only at the glories of the earth and of the cosmos that surrounds us, of which we humans are unarguably a part, but also, and sadly, at the misanthropic undercurrent often found in discussion of other worlds. Christian Huygens asked in 1698, quote, whether nature has laid out all her cost and finery upon this small speck of dirt, unquote. In 1755, Immanuel Kant's brilliant cosmology offers the analogy of anthropomorphized lice who, quote, live in the forests of a beggar's head and thought of their dwelling place as an immeasurably large ball and themselves as the masterworks of creation, unquote. This insect, Kant continues, in its way of living as well as in its lack of worth, expresses very well the condition of most human beings. Admittedly, the analogy is pretty funny, but really, misanthropy is gratuitous. In the book, we cite further examples from Fontenelle and others. And you can come up with your own in reading that sort of literature. In Kant, we also glimpse POW theorists' love of analogy, to which we devote a full chapter. John Wilkins, who's a great favorite of mine, most notably in his 1638 discovery of a world in the moon, building on the writings of Galileo and Kepler, declared that if the Earth is a planet, surely the other planets, including the moon, must also be Earths. This analogy, though just an analogy, not a proof, continues to flourish even long after the other planets in our solar system came to be recognized as not other Earths. Pace Mars, Pace Musk. Two other features of POW thinking I'll lump together for the sake of brevity. One, the issue of cosmic plenitude, to which Chris has already alluded. And two, what we call the big numbers maneuver. The quickest way to illustrate these is with reference to the 1997 movie Contact, based on Carl Sagan's novel of the same name. The story's main character, Dr. Ellie Arroway, is played by Jodie Foster. Ellie's romantic interest in the film is Palmer Joss, played by Matthew McConaughey. And the following dialogue takes place as Ellie and Palmer together gaze up into the night sky while sitting by the Arecibo radio telescope. And you must forgive me for my really lousy rendering of Jodie Foster's lines. Ellie, there are 400 billion stars out there, just in our galaxy alone. If only 1 out of 1,000,000 of those had planets, all right, and if just 1 out of 1,000,000 of those had life, and if just 1 out of 1,000,000 of those had intelligent life, there would be literally millions of civilizations out there. Palmer, well, if there wasn't, it would be an awful waste of space. Ellie, pause. Oh, man. Ellie is, in effect, walking Palmer through a simplified Drake equation aimed at estimating how many civilizations might exist in our galaxy or even in the universe. Ellie's big numbers maneuver and Palmer's response reflect a centuries-old feature of the case for plurality of worlds. Ralph Cudworth wrote in 1678, quote, "It is not reasonable to think that all this immense vastness should lie waste, desert, and uninhabited, and have nothing in it that could praise the creator thereof, save only this one small spot of earth," unquote. Even the openly atheistic Ellie, with her reverent amen, an affirmation usually reserved for faith-based statements, oddly resonates with Cudworth. Palmer's waste of space comment echoes a long-standing argument for the existence of extraterrestrials that likewise reaches back hundreds of years. Arthur Lovejoy dubbed this the principle of plenitude, the idea that a perfect creation must in some sense be full, with no gaps, for God's creativity tends to fill all the places God creates. Back in the 16th century, Marcellus Pelaginius, a pre-Copernican, asked regarding Earth, "Shall then so small and vile a place so many fish contain, such store of men, of beasts and fowls, and the other void remain? Shall skies and air their dwellers lack? He dotes that thinketh so." From Aristotle right through to Descartes in the 17th century, it was common wisdom, as you know, that nature abhors vacuum. Are Palmer and Ellie embracing this ancient and medieval way of thinking? Are they embracing its teleological and theological assumptions? Surely not, at least not knowingly. But absent teleology and absent theology, it's hard to grasp what the waste of space appeal is intended to prove. Certainly after the work of Blaise Pascal and others who empirically established that nature does not abhor a vacuum, modern science, including modern astronomy, has found nothing ridiculous or objectionable in the idea of empty space. In any case, Chris and I present the unfolding Copernican universe, the starring of the Earth, as releasing our planet from its alleged status as small and vile. Certainly it is cosmically small, but gone are the pre-Copernican reasons for considering Earth, as Pico put it in 1486, the excrementary and filthy parts of the lower world. Moreover, on that issue of smallness, we argue that it's pointless to disparage ourselves and our planet for being cosmically minuscule in size, when our very existence is cosmologically predicated on the staggering disproportions between our smallness and the inconceivable largeness of the universe. Perhaps those vast empty spaces are simply necessary, not wasteful. And finally, this freshly grasped Copernican vision of our planetary Earth, framed by the familiar picture of our blue marble against a pitch black background, is not debilitating or discouraging, but instead exhilarating, humbling, even overwhelming. We decisively are participants in something genuinely special. We do inhabit this picture and that history. To ponder this message is to taste, if fleetingly, what is meant by the word miraculous. It's like beholding the face of a newborn child and realizing the contingency and glory of a creature unique in the history of the universe. Sensing, too, the burden and the privilege of caring for it. And in this way, we also hope that the story we tell might encourage the cherishing and protection of what does seem to be our only home in this physical universe. Thank you.
So those are our comments, and now I'm going to start off with Brother Guy. I know how long he's talking. It's 4 minutes. So these are his commentary.
Hi, just a few comments on Graney and Danielson's work, Starring of the Earth. And the theme of this conference, which is visual, seeing things. There are two different ways that expectations affect what we see and how we see. I'm reminded of a story of a friend of mine who was learning geology as a student and was taken out to a road cut where you could see all the different rocks that just looked like, a bunch of rocks that the road had run through. But the professor had explained how you can look at those rocks to see the history of what the geology was going on when those rocks were formed. And the way my friend put it, if I hadn't believed it, I would never have seen it. The interesting inverse to the usual cliche. But there's two different things that you have to worry about, and two different things that you see going on in the plurality of worlds debate. The first is seeing what you want to see, and the second is seeing what you're afraid you're going to see. So in one case, you have to know what you're looking for to be able to know to look for it, to be able to see it. And that's just the way that science works. But in the other case, we also have to recognize that our own human impulses, whether it's what we're guessing we're going to see, like the famous video of the basketball players passing a ball back and forth, and as you're counting the number of passes, you don't notice the gorilla walking through the basketball players. Or the people, as in the plurality of worlds situation, where there is such a desire for there to be other worlds that you interpret the data and you interpret the very things you're looking at in such a way that you see oceans on the moon because you want there to be oceans on the moon. You see canals on Mars because you want there to be intelligent life and signs of intelligent life on that planet. It can be good and bad. Obviously, it's bad when it leads you to see things that aren't there. But you also have to respect the fact that these desires make us want to look in the first place. And so it's not entirely a bad thing. The other version of that, of course, is when you're afraid of what you're going to see and you wind up seeing and reading into the things that you're most afraid of. I think this is common in personal relationships or relationships between countries. We can all think of times when we tried to say something to soothe somebody and they did not want to be soothed, and they heard what we said in the worst possible way. The wonderful scene in the Marx Brothers movie Duck Soup, where Groucho Marx is getting this reconciliatory comment from the enemy country and starts saying, what if I shake out my hand and they don't? And then creates this entire scenario in his head of all the things he's afraid they're going to do. It's played for laughs. It's funny because it's common. And this also can be the way that we interpret the things that we see. I think the lessons for us are, first of all, to recognize, of course, this is going to happen. That's not news. I think we all knew that. To account for that in the things and the reactions and the science that we do when we are looking at things. But also the importance of holding on to the raw data so that even if we are misinterpreting what we're seeing, what we have seen can be used by people with a different set of expectations and a different way of looking at the world. My two thoughts.
All right. So, guys, the first of the three people who got a look at a late draft of it, and either one of you guys want to go next? Or? Okay. All right.
Well, okay. Chris and Dennis's book and their comments reminded me of a couple of things. One is a person I quoted in one of my books, Norman Lamb, who is actually Rabbi Norman Lamb, who was discussing extraterrestrials and how people think they're so much more advanced. And his comment was that never before have so many been so enthusiastic about being so trivial. Which I think, in a way, is the kind of the theme of your book. I think it's true what Brother Guy just said also. Let me see, I advanced this by doing that. This is a picture on the right there of the auditorium at NASA headquarters, where I've been many times, but I've never quite seen the scene like this. This is 1996, when it was announced, NASA announced the possibility of nanofossils, tiny fossils in a Mars rocket had been found on Earth. And there you see part of the evidence on the left there. So you see the media frenzy here. And I agree that there's certainly a will to believe that there's life on other worlds. This is just a nanofossil. This isn't microbes or intelligence. This is just a nanofossil. And of course, it took a while, but after a lot of years of discussion, the consensus was that this is not biogenic. This is just an artifact. And a lot of what we're talking about here today goes to philosophy of astronomy, because there were arguments made, I think 5 independent arguments that this was actually a nanofossil. And the question was, when you add up 5 arguments, do you have 5 weak arguments or 1 big strong argument? Well, that's a kind of a philosophical question. But anyway, just to show that there's a lot of excitement about this, there always has been, and there continues to be. Let's see. The other thing that I was reminded of was when I first asked to do my, or proposed to do my dissertation on the idea of a plurality of worlds originally from the ancients to the present, which would have taken forever. But in the history of science department down at IU, they said, well, there are 2 problems with that. First of all, it's not science, and secondly, doesn't have a history worth writing about. That was the reaction of Vic Thorne, who was the resident historian of astronomy. Luckily, Ed Grant, the medievalist, knew that there was a medieval plurality of worlds tradition, so he became my advisor, and my dissertation then was on the plurality of worlds debate from the ancient Greeks to the mid-18th century, because that's, after 4 years, that's where I was. It was a big arc from not believing in other worlds to very widespread belief. So what I showed, well, let me say first that I think there are two contrarian arguments in their comments and in their work. One of the contrarian arguments is that the search for life is not really science, or it's bad science, or it's at the limits of science. And the second contrarian argument is that we live in an anthropocentric world. I think it's a hard argument for anthropocentrism in your book. Would you agree? Well, from what you just said also. And contrarian views are good. I like contrarian views. And this is an example of contrarian views in astrobiology, because there was, for years, a fight over this kind of thing, just over the nanofossils. So contrarian views are good, and they might even be true. So they keep us on our toes. So I appreciate what you're doing there. So what I showed in my dissertation, though, was, after Vic Thorne said, well, this isn't really science, what I showed in my dissertation and subsequently published at Cambridge University Press was that how this was related, this idea was related to cosmologies, not just some wild idea, but was related to cosmologies from the ancient Greeks to the mid-18th century. So, for example, the ancient atomist idea of an infinite number of worlds, and Aristotle's idea that there was only one world in the sense of cosmos, and then the Copernican idea, which has been mentioned, making the Earth a planet and the planets potential Earths, and then the Cartesian idea of the plurality of solar systems, and finally the Newtonian idea. And let's see here. So here's your basically geocentric system, and the argument even about this is whether in ancient times this was believed to be a good thing or a bad thing. We're obviously physically located at the center, but it's also been argued by Dennis and others that the center was actually the dregs. After all, the Earth is corruptible, and as opposed to the heavens, which are not corruptible and unchanging. So anyway, that's Aristotle argued that there was only one such cosmos like this, and that's what the discussion was through the Middle Ages. And with Copernicus, obviously, you have the sun in the center, the Earth is just one of the planets, and the question is how much like the Earth are the other planets? And that's been a big question throughout the history of astronomy. Here you see planetary systems in the Cartesian tradition. Descartes believed that the universe was a plenum. You had vortices that formed of necessity. So by necessity, you had this infinite number of worlds. And on the right side, you see Fontenelle's version of that. You see this throughout the 17th, 18th, and 19th centuries. And once you see something like this, talk about images, once you see something like this, it's hard to unsee it. That's kind of how you imagine the universe to be. And here it is with William Durham, who was a Newtonian. On the top there, you have the geocentric system, then you have the heliocentric, and now he's saying we've evolved to this new system with multiple solar systems. And notice this was in a book called Astrotheology, because his argument was that not necessarily in the Newtonian system do you have a plurality of solar systems, but from natural theology, it would be a better universe if there were lots of solar systems out there that were populated. So here's another view of Thomas Wright of Durham, a Newtonian. And again, once you see these, it's hard to unsee them. Well, this whole history has been done and has been written in my books and in Mike Crow's, Carl Guttke's there. And the Biological Universe book, the subtitle is The 20th Century Extraterrestrial Life Debate and the Limits of Science. So I do agree, we are working at the limits of science here. This is not, something that's an easy thing to prove, and it certainly has not been proven. I'm always amazed when I look at this image. This is Alfred Russel Wallace, co-founder of the Darwin theory of natural selection. And this is, 1905, I think, or 1903 there. And it shows how he believed that we were basically at the center of the universe, which was, 3,600 light years across. That's 1905, just a little more than a century ago, that they believed this was the whole universe. And Wallace was driven by this idea of anthropocentrism. So you can be driven by preconceptions in the other sense also. Astrobiology as a discipline, I think you argue in your book that astrobiology, or the Plurality of Worlds, is not very scientific, but here I show the very the components of astrobiology as it exists today: planetary science, planetary system science, origins of life, SETI, and if you want to respond whether you think none of this is science, there are thousands of scientists around the world working on this. Interestingly, the social science and humanities are also involved, and education and public outreach. And it is realized that the media tends to sensationalize things, and NASA's had various meetings to try and inform the media that this is a difficult subject and we don't know for sure, and you should not make wild claims, which they tend to do, of course. And these are just, again, some of the robust things that are going on in the discipline of astrobiology. The other thing I wanted to emphasize is that science, is not just observation and theory. Science is also consists of preconceptions, and I like very much the work of Iris Fry, who's an Israeli historian and philosopher of science, who wrote this article on the philosophy of astrobiology, and she points out that preconceptions are also a part of science. And for astrobiology, the two preconceptions are the Copernican preconception, as you see there, the Earth is not unique, and the Darwinian preconception that terrestrial life emerged and evolved naturally and might do so elsewhere. And various people can have various preconceptions. A.R. Wallace's was that anthropocentrism is the preconception. But data gives credence to both of these preconceptions. So these are the preconceptions that are laid out by astrobiologists. That's what they start with. The whole thing about astrobiology is to go out and show it. That's what the science is all about. Of course, you can't assume what you're going to prove, but you can have preconceptions. I think most scientists have preconceptions in the fields that they're working on. This is just to show in opposition to what Dennis and Chris say. These are two historians of scientific revolution. E.A. Burt on one of my favorite books, and Florence Cohen just has written this recently, that the humans were central prior to the scientific revolution, which I think is the opposite of what you say, Dennis, right? The Copernican cliché. So this is just another view. This is their view. This is a standard view, and yours is a contrarian view. Yeah. Oh, I have to say something about Bruno, right? So every time I go to Rome, I have dinner with Giordano Bruno here in the Piazza Campo dei Fiori. I think some of you who've been here for quite a while will remember it was back in 2015 that Alberto Martinez argued that the Bruno's burning at the stake was due, at least in part, and maybe mainly, because of his belief in other worlds, which is contrary to what most people say, but I think it's an argument that is pretty robust. So there are consequences if you believe that there's life on other worlds. There are lots of consequences. This was one for Bruno. And I've written about this in Astrobiology Discovery and Societal Impact. Finished?
Yeah, we're good.
Yeah, okay, I just have one or
shot.
two more things, yeah. Talk about theological implications. There's a robust literature now on what the implications might be, written by theologians and humanists and all kinds of people, including Brother Guy there on the left. Would you baptize an extraterrestrial? His answer is, only if it asks, which is an improvement right from the 16th century.
Only if she asks.
Only if it asks, or whatever, yeah. Okay, so I think I'll quit with that one. But so there are consequences to these different worldviews. Yeah.
So, my remarks basically have to do with this general outline. So, I'll try to comment on this and give you some illustrations. So basically, these preconceptions, there's one that I'm always missing in these debates. Old preconceptions are difficult to identify because we don't have them, but people used to have them. And they were so ubiquitous that they didn't write about them at all. That's what you do with preconceptions. You never actually reflect on them until something happens. So one of these very important preconceptions that existed for a very long time is something that is still present in our language in many ways. It's this preconception that there is a fundamental difference between the world that we inhabit, the earth, so to speak, and the celestial world above us, which is somehow fundamentally different. And this preconception existed for a very long time. And as I've said, even today, there are many traces of it left in our language, in our phraseology. So my question is, how did it happen that this preconception disappeared? And I would argue that the important figure here is Nicholas of Cusa, who I'm sure most of you have come across, but I'll still spend a little moment talking about. So he has this wonderful, strange book called Deducta Ignorantia, which is a book he published in 1440, and he didn't just publish it, he actually went around and spoke about it at length, and still didn't help because most people didn't understand what he was talking about. And we still have trouble understanding a little bit the nuances of his thought. So essentially what is he talking about is that since he's coming out of a rather Platonist view of the world, and he says that in the material world there can be no perfection, therefore you can't have these homocentric spheres forming the universe. Right? And from that he deduces that there can't be any center in the universe. And he kind of looks at it as a mathematical finding. So if there can't be a center, well-defined center, the whole concept of Aristotelian thinking, which uses the concept of center as defined by falling bodies, right? So it's an empirical concept, to produce his proof of the uniqueness of this universe, etc., etc. So this Aristotelian construct is basically goes up in smoke. So he has to replace it. I mean, Cusa has to replace it with something. And he's saying, well, what can we deduce from this is quite earth-shattering, literally, in a way, because what you see there, that if the Earth isn't at the center, it's going to be just one body among many, and that is, in fact, one way of looking at it is that it is a star. And by star, of course, in Cusa's day, he meant planets, not what we would call stars. The fixed stars in his day were something perhaps different, just reflecting sunlight, maybe, bits and pieces of shiny ether inhabiting the sphere of fixed stars. not actual bodies. But we don't quite know what Kusa thought about the fixed stars in general, but definitely he focused only on bodies which we would call solar system bodies in his thought. So he says that if the Earth is among any solar system bodies, or just one of them, the other solar system bodies are going to be like the Earth, and so they could be inhabited. And herein comes a fascinating precursor to the theology of aliens, where Nicholas of Cusa says that some aliens could have very different relationship to God than we do. The aliens inhabiting the sun, for instance, would be so full of light and grace that they would never need to be saved, for instance. And the aliens inhabiting the moon are going to be lunatics, and things like that. So they would also be very different in their relationship to God. By the way, this whole question of anthropology, anthropocentrism, that is also a very ancient question that has a lot to do with theology. So essentially how we view ourselves and whether we are inherently good, inherently evil, that kind of stuff. That is very much something that can be used as a very interesting prism for trying to study the history of theology. Anyway, but it has very much to do with cosmic pluralism, obviously. So going back to my slide here with this. So I would say the first thing that happened, that had to happen, is that somebody had to say that there is no heaven and earth dichotomy. The earth is a celestial body. That had to happen before Copernicus could do anything. And that's why, in any discussion of the Copernican revolution, so-called, I miss that point. Now, the second point that I would like to mention is that going back to these nice pictures of the plurality of worlds according to the ancients, that is to say the ancient Epicureans primarily, this type of cosmic pluralism where you have essentially universes that form in a haphazard manner and they don't really have any purpose. This is the sort of thing that we have come across now again in the context of the fine-tuned universe and the attempts of various cosmologists, physical cosmologists, to explain away the fine-tuned universe by saying that in fact there are infinite universes and ours just happens to be the one we inhabit, and therefore it looks fine-tuned to us. So this is something which is also present. Now the second stage, of course, the many solar system bodies that have biospheres, that is something which is very present, as Steve was just pointing out, in the search for life in the solar system, and it is a very productive and very interesting field of science. Now, when it comes to my second point here in white, that's transition between, the plurality of solar systems, single solar system and a plurality thereof. So that I think is primarily a concept about the fixed stars and whether the sun is one of them or not. So this is a second step in my mind. And here, of course, we have reached a point where over the last few decades, we have become much more aware of the presence of planets outside of the solar system, of exoplanets. And this is quite a fascinating subject which I study myself, and it's fascinating because right now we are somewhere in the reaching about 6,000 exoplanets in various parts of the universe, and very close to the Earth, in fact, for the most part. But what we have found, in fact, is that in spite of the fact that there is about 6,000 of them, we haven't really seen a good Earth analog yet. And also the architecture of those solar systems seems to show that they are very different from the solar system that we know and inhabit. So this is very briefly what I wanted to point out. And Fontenelle himself has this nice passage where he says, well, this is in the introduction to his Entretien sur la pluralité des mondes, where he says that essentially which I recommend, it's only about 5 pages. Basically he says that the theology of aliens is something that he would very likely, he wants to leave to theologians, he doesn't want to talk about that, which is, I think, a very good approach. So, because after all, as one of the theologians that I lived with in my Jesuit life used to say, well, I asked him about some specific questions about the theology of aliens, right? So he said, well, have you ever met an alien? And I said, well, not that I know of. And he said, well, if you do, just invite him to dinner and we'll talk theology. Basically, the realm of the possible is so large that it's very difficult to make any assumptions. But the assumption, in fact, that this is a very interesting field of study, I think, remains, and it touches upon a lot of things in philosophy and theology, as well as in science.
So I did not ask for probably enough time for this thing, but that's okay because we can be short. So I'm going to sort of wrap up a couple comments and then we'll the questions will probably have to be limited and best done in other discussions anyway. There's too much to be really hit on. Thank you all for your comments. I think that if I was going to sum up things, I think that Dennis and I each had to come at this from different perspectives. My wife told me she read something that the best collaborations are with people who are widely different in their areas of expertise and things like that. You can tell from Dennis's discussion, right? Dennis, if it went Notre Dame, but a Catholic school, Dennis's view on this is very Laudato Si, the value of Earth. My view is, looking at this, well, look at what this star size data means for this question, I think that I like both Paul's and Steve's comments. I do not think that, I think Steve, you tend to see more in what we're saying than what we say. So I wouldn't say, for example, that these things don't qualify as science or things like that. But you guys can make hopefully we've interested you in this book. It's supposed to be out in February and interested you in this question. And you can read it, and there's a lot of it, and see what you think. So, Matt, do we have any time for questions? Sure. We got to call it quits. Okay. True, you got your hand up first.
I'm under the impression about the exoplanet research that there are limitations to what it's able to detect, and that the hot Jupiters, I seem to remember hearing somebody say that it's mainly, it'd be hard to detect something the size of the Earth. And so it's detecting things that are closer and larger. And so there's actually built-in scientific bias toward larger and closer planets and not necessarily get out to the rocky planets. And I'm wondering if that is correct, and if that could affect the distribution of planets that's been detected so far.
Sounds like a Paul question to me.
Yeah, so it's absolutely correct that there is a methodological bias, but we can correct for that. So we can have a statistical model of how many stars we would expect, of different sizes of stars we would expect to have what kind of planets. And you can have different models, statistical models, and you can then look at, what you are expecting to find if this model is correct. So you can, even from the limited sample that we have, and the sample is biased by the limitations of the observational methods we use, we can still deduce the general numbers, correcting for those biases. Obviously, there is a certain uncertainty that is introduced by these corrections, but these methods are relatively robust, and even then, it turns out that the Earth is fairly unique. But of course, it's early days. I always like to say that the exoplanets research is essentially something like when the naturalists of the 18th century started collecting butterflies. They made no sense or reason out of those butterflies. They just had a collection of them. And it had to be somebody like Darwin, 100 years later, who actually came up with something that explained the diversity of the butterflies. So we are kind of at that point, I think. We're collecting the exoplanets. We've got 6,000 of them, and we're very, very proud of ourselves that we've got them. But, obviously there's a lot more to be discovered.
Paul, can I add something on that? I think actually that's like a really good general question for this discussion, because let us just, Paul said, 6,000 exoplanets, Earth seems to be fairly unique, right? But the universe is very big, okay? So let's just suppose as a starting point that Earth is unique among 6,000 planets. But given the number of planets in the universe, that still leaves room for lots and lots of Earths. On the other hand, it does mean that those Earths would be rather spread out. And so it is not a universe full of other Earths. In other words, and so if you were going to propose that Oumuamua is a piece of space tech, that's passing through the solar system, that requires, enough people enough other Earths close by for their junk to blow into your backyard. And, so these mean there's two things involved in the same thing. So, Steve?
Yeah, no, I certainly agree that, scientists sometimes tend to get out over their skis on their claims. But I think it's self-correcting. And eventually in science, as with the Mars rock, a consensus is reached on what the truth is. And it's certainly true of the media that they get out over their skis, clickbait and all that sort of thing. But I think overall that the search for life, if you consider those preconceptions, you and Dennis seem to have a different preconception than the two there. Is that a fair statement?
I don't know.
The Copernican and the Darwinian? Yeah. So,
I don't know that we would have different.
okay, all right. But the astrobiologists, fully state that that's their preconception, and the problem is to go out and see if it's true or not. That's what astrobiology is all about. And in a couple of weeks, I'll be going to Iceland for the European Astrobiology Society meeting, where there'll be about 700 people who are doing this kind of work. So I'm hoping you're not saying that that's not science.
No.
Okay.
No, I'm not. Yeah, and this is where I think Steve's way over reading what we're saying. But you can decide for yourself when you get a hold of the book. I think that I really like to go back to I like Paul's exoplanet numbers, and looking at what is it that we think the universe looks like, and why do we think that? And in particular, our argument involves historically, what is it that astronomers expected and what is it that they found. And historically speaking, the universe has not panned out to be, Mars is not like Earth, Jupiter is not like Earth, the moon is not inhabited, the sun is not inhabited. Those weren't necessarily stupid ideas at the time. If you believe that matter naturally generates life and it generates it in all sorts of different forms, and whatever it generates, whatever is suitable survives, it makes sense that there's life on the sun. So there are, I do think it's important to look at where the ideas that we have evolved from. And for me, finding out that Kepler was busy arguing against Bruno, not because of, his theology or stuff like that, but because of his observations of the stars. And Kepler was saying, those things are not suns. Bruno is not correct because those are not suns. My telescope observation shows it. And yet the idea catches and sticks anyway is significant. And I don't think it makes it not science, right? But I do think that when we're doing these things, we should know that this idea caught and stuck, contrary to some pretty basic stuff. And Matt, I see you standing up, so I think we're probably running out of time here. So
I think we are.